Let's do lecture example number 8. Now, lecture example number 8 gives us a Ka value. It says that Ka is 1.74 times 10 to the minus 5 for something called ethanoic acid. And then it gives me a formula for ethanoic acid. It's C2H3O2. And so it asks us, what is the H plus concentration and the pH? So once I find the H plus concentration, I can find the pH pretty easily. So what's the H plus concentration and the pH for a solution that has an equilibrium concentration of ethanoic acid that equals 0.50 molar? All right, so ethanoic acid, HC2H3O2, is going to dissolve in water. So it's going to be an aqueous compound. Now, some of it is going to dissociate. So that hydrogen out front, that's why they didn't write it as C2H4O2. This hydrogen is special because that's the hydrogen that can come off and then make the solution acidic. So, and it's an equilibrium because this is not a strong acid, it's a weak acid. I also know that because they gave me a Ka value, but I also could recognize it by the fact that it's not one of my 7 strong acids. So that H plus comes off there, and that's going to be aqueous. Any ion is always aqueous, but we'll write it there this time. And then it's going to leave behind the C2H3O2. And since that's a positive 1, this guy's got to be a negative 1. And I guess that would be an ethanoate ion, right? That would fit our naming convention of 8's become ic acids. All right, so there's our equation for what's going on, and then we can write an equilibrium expression. And so K is going to equal the concentration of the products, which there's my H plus, which is what I need to solve for, times that ethanoate ion over the concentration of C2H3O2 that dissolved but did not dissociate. Now I want to find H plus. They gave me the K value. So the K value, the equilibrium constant for this, is 1.74 times 10 to the minus 5th. And they gave me the equilibrium concentration of the ethanoic acid. The concentration of the ethanoic acid is 0.50 molar, and that's the acid that did not dissociate. So 0.50 molar. I want to find H plus, but I don't know the ethanoate ion concentration, so what can be done? But if we look back at this balanced equation, every time X amount of this dissolved or dissociated, it would have to make X amount of H and X amount of ethanoate. You cannot make one without making the other. So these two concentrations would have to be the same value. So I have one unknown multiplied by itself. So I am going to, on the top of this equation, sub in X times X, and mathematically it would actually make it easier on myself. Rather than write X times X, I'm going to write it as X squared. So on top of that equation is going to go X squared, because the concentration of hydrogen ion and the concentration of ethanoate ion have to be the same. Now when I solve for X, it would represent this concentration, it would also represent this concentration. I don't really care about the ethanoate ion concentration, but it will give me this guy, which I'm very interested in. So then you multiply the 0.5 over and take the square root. So let's find what is the square root of 1.74 times 10 to the minus 5 multiplied by 0.5. That'll equal x. All right, and I get that x comes out to be 0.0029 molar. So that is my H plus concentration, 0.0029 molar. Or you could write that as 2.9 times 10 to the minus 3. And then to find the pH, we're going to take the negative log of the H plus concentration. So let's find the pH. The pH would be 2.5. How many sig figs? 2. All right, so pH comes out to be 2.5. And that's how we do it.